Welcome to the Mathematics MI channel. In this video, we are going to solve this interesting integral from 0 to 1 x to the 2 times n arc sine of x dx is equal to 1 over 2n plus 1 times pi over 2 minus 2 to the n times n factorial over 2n plus 1 double factorial. Well, first I am going to take our integral is equal to I, and then as a first step we can integrate by using IBP. So we can write integral from 0 to 1. As a first function, I am going to take arc sine of x. So arc sine of x times d by dx, then integration of x to the 2n, we know x to the 2n plus 1 over 2n plus 1 dx. Then we know product of these two functions. So arc sine of x times x to the 2n plus 1 over 2n plus 1 from 0 to 1, then minus rewrite this function. So here 1 over 2n plus 1 integral from 0 to 1 x to the 2n plus 1 times, now derivative of arc sine of x, we know 1 over 1 minus square root of 1 minus x square dx. Well, then if we apply limit, if we apply 1 here, arc sine of 1, we know pi over 2, here 1, so we have pi over 2 times 2n plus 1. Then if we apply 0, we know arc sine of 0, 0. Then here we have 1 over 2n plus 1 integral from 0 to 1 x to the 2n plus 1 over the square root of 1 minus x square dx. Well, I am going to take this integral is equal to j, and now we are going to evaluate j. Okay, to evaluate integral j, we can take first let us simplify a little bit. Here 0 to 1, now x to the 2n plus 1, we can write x to the 2n times 1. X to the 2n, we can write x square raised to the n times x dx over 1 minus x square. Now we can use a substitution. X square is equal to u, then differentiate, so 2 times x dx is equal to du. Now we can apply here, we can substitute. Now limit, we know also 0 to 1. Here x dx, we know du over 2, so 1 half outside of the integral sign. X square, we know u, so u to the n. Here du over square root of 1 minus x square, we know u. Okay, then I'm going to rewrite our integral. J is equal to 1 half integral from 0 to 1 u to the n 1 minus u to the, we know here square root sign, we can take to the numerator, so here minus 1 half du. Now still we can write now this power n plus 1 minus 1. I think you know why I rearrange these powers. Here we know 1 half minus 1 du, because we are going to apply beta function. I think you know about beta function. The formula of beta of AB is equal to integral from 0 to 1 t to the a minus 1 1 minus t to the b minus 1, a and b greater than to 0, here dt. So we can write j is equal to 1 half beta of, now instead of a we have n plus 1, instead of b we have 1 half. Okay, then we know relation between beta function and gamma function. Beta of mn is equal to gamma of m gamma of n over gamma of m plus n. So now we can write our integral j is equal to 1/2. Now here gamma of n plus 1 according to this formula, gamma of n plus 1 gamma of 1/2 over gamma of n plus 1 plus 1/2, so we know n plus 3 over 2. Okay, then here 1/2 gamma of n plus 1 we know n factorial, gamma of 1/2 we know square root of pi, and in the denominator we have gamma of n plus 3 over 2. Now how to remove this gamma of n plus 3 over 2? Well, we know legendary duplication formula. So this is the formula, gamma of x times gamma of x plus 1/2 is equal to 2 raised to the 1 minus 2 times x times square root of pi times gamma of 2 times x. In a previous video I proved this formula. I will add the link in the description and also make a card. Here we have gamma of n plus 3 over 2. Therefore instead of x I am going to apply n plus 1. So here gamma of n plus 1 times gamma of n plus 1 plus 1/2 we know 3 over 2 is equal to 2 raised to the 1 minus 2 times n plus 1 times the square root of pi times gamma of 2 times n plus 1. Okay, now we need to 1 over gamma of n plus 3 over 2. So we can isolate 1 over gamma of n plus 3 over 2. So we have here gamma of n plus 1 we know n factorial, and then here if we simplify minus 2 times n minus 1, so 2 raised to the 2n plus 1 over here square root of pi times gamma of 2n plus 2 we know 2n plus 1 factorial. Okay, then we can write now j is equal to 1/2 here n factorial times the square root of pi and here 1 over gamma of n plus 3 over 2 we know we have here the square root of pi 2n plus 1 factorial times here n factorial times 2 raised to the 2n plus 1. Okay, then we can simplify. We know square root of pi get cancelled, and now we have here 1/2 n factorial square, so n factorial is square, and here we can write 2 raised to the 2n times 2, so we can write 2 raised to the n square times 2 over 2n plus 1 factorial. But we know this relation 2n plus 1 double factorial is equal to 2n plus 1 factorial over 2 to the n factorial. So we can write instead of 2n plus 1 factorial we can write 2n plus 1 double factorial, 2n plus 1 double factorial times 2 raised to the n times n factorial. Okay, now we know 2 raised to the n get cancelled, this 2 get cancelled, this n factorial get cancelled. Now we have j is equal to here 2 raised to the n factorial, so n factorial 2 raised to the n over 2n plus 1 double factorial. Okay, then we know our main integral I is equal to pi over 2 times 2n plus 1 minus here we have minus 1 over 2n plus 1 times j. Okay, then now we can take 1 over 2n plus 1 as a common factor, so 1 over 2n plus 1, and here we have pi over 2 minus, now j we know 2 raised to the n times n factorial over 2n plus 1 double factorial. Okay, this is the answer for this integral.